This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Good morning, afternoon, evening, dear listener, wherever you are.
Peter, good morning. Let's start with the news part. What do you have?
What do I have? I started with the Industrial AI Cloud.
Oh, what is that?
Yeah, that's a partnership. It's a 1 billion, right? We call it partnership between Deutsche Telekom and NVIDIA. I think I said it before. I mean, these days, and especially if you're not in the English language world, I mean, you don't know. We say, and then in German we say Milliard, and that means a billion. So it's only a 1 billion.
It's a small one, right?
Yeah, well, you hear about these 500 billion, etc. So I'm calling Colin Masson from ARC. He talks about it. So what is going to happen is that there's going to be this industrial AI cloud, which in itself is, of course, more specifically interesting for us than in general. There should be a data center in Munich. You've been living here. They said it's going to be in the Tucher Park. That's only interesting for the people living here in Munich. It's close to the English Garden. Many people also who do not live here may have been there. Should go live first quarter of next year. It's going to be powered by 10,000 NVIDIAs, same thing as before. You know, other announcements from the United States typically have 100,000 of whatever, the latest Blackwell. Now, I think the big thing here is this digital sovereignty, which we can talk about a little bit within the European environment, I think, and I do not always like that too much, but it is a topic, I guess, is this digital sovereignty, not an easy word, is an important thing, right? There is a core alliance of, I believe, 4 companies, Deutsche Telekom, right? Which is, I guess, since maybe in the meanwhile, 20 years also a brand on the US market, right?
Absolutely. A big brand, yeah.
Yeah, right. Since maybe 20 years. NVIDIA, we know them. SAP, we know them as well. I hadn't heard from SAP for a long time. I say it's not directly, although I must say, as part of doing the podcast recorders for OPC Foundation, they have been involved also within the industrial space, but I hadn't heard from them that long. It's the only, we could say, a software European player on the market, right? And of course, Siemens as well. Those 4. And without going in too many details, if you are interested, I think Colin did a very good analysis. The only thing I'm going to talk on the differentiation he is making between sovereign by contract and sovereign by origin. I think what he calls sovereign by contract is what typically the US companies, and I think he's mentioning those companies that are not part of this deal explicitly, like Microsoft and AWS, so the big tech cloud providers who do say on paper that that they will provide sovereign solutions for their European customers, and then it's always but then if your mother company is going to want to get, or if the US government wants to get to our data. So that is the discussion, as opposed to what he calls this sovereign by origin. That's a platform EU owned, right? Now, there was an example. As I said, it's a huge topic. We hear about it all day, everywhere. It's about the office apps, certain companies. I think there was this thing with the Hague. There is this institution. They moved away from. When we talk LLMs, we know there is, of course, we have European solutions. And then certain people are very, very very proud, and we should be proud that we have them. Then we talk open source, and we talk about buying Airbus instead of maybe US fighter jets. There's huge discussions every day. Everywhere. And there was this one I thought was so interesting, was related here. There was a sovereign AI journey. That was a Siemens post. It was about building a self-contained, sustainable, and cost-effective LLM platform. And then I said, I'm not sure how a GPU fleet, that's also about NVIDIA L40S H2200Os, represents what they had been talking about, AI sovereignty, owning the entire stack. It's kind of a definition, powering the generative AI applications from the silicon that crunches tensors to the orchestration software. Because, of course, NVIDIA chips are NVIDIA chips, right? They are US designed. So, and then Erkan Ucan or Utsan, not sure how you pronounce it. He's a senior key expert, a senior software engineer with Siemens, who says, because the GPUs are running on-prem. So that's part of that discussion. Well, I guess, doesn't mean there's no connection to the outside. Right. So that's what I wanted to share, this discussion going on. Not sure how you're experiencing this discussion of the sovereignty.
Yeah, it's a huge topic for some industrial companies. But for example, we do not hear so much from Siemens because I think they're acting globally, right? So if you want to be a global player, you have to play the rules in the different countries. So there's a European strategy, there's a US strategy, there's a Chinese strategy. And if you want to make business in all the different countries, you have to play the different rules.
That's a very good point. Why we may not specifically, and then probably politically, you don't want to then be too loud about specific opinions that you may have or not have, and we are not doing that either. We don't want to be political, but nevertheless, we do want to talk about what we see happening in the market. So maybe let's keep it at this for the moment. I mean, and that was this with the example of the question that I had. I mean, I think we've been writing about it in our book together, the one that I did afterwards. I mean, I recall what I've been saying is like, where are we standing? You and I did that, and we said, the US, we had, and I need to just say it one more time, at that time, Intel, a 4004 microprocessor. By the way, I was looking into GPUs as well, but don't let me go there. I saw that Jens got awarded by the king. Mm-hmm. He is the king, right? Like I have a king of the UK for his work in developing or in, GPUs. And then I saw what I'd been doing many years before with Psycho Instruments, with loads of graphics processors. It was amazing. I was reading the article there. So it's all about who was there first with these developments and where are we moving?
Absolutely. When you then promote European solutions, that's a good point to do that. But at the end, you must be competitive, right? So if you do not have competitive models, you have a problem. So if you have not competitive software, you have a problem. If you don't have competitive GPUs, you have a problem. So right, and that's exactly the point. I live not too far away from the Infineon head office, and there you go. They are a very important, very successful silicon company, but they have different type of silicon, right? It's a silicon that goes into automotive, like this other company we hear about, Dutch company Nexperia, which is, again, all about politics we don't want to go into, but they are not the GPUs that especially Jensen, NVIDIA, has been building for the last 25 years. So, but that will be an example. If you say you want to be sovereign from the base up, then you start with the microprocessor, with the silicon, right? So you need to design the silicon, and then you go to all the levels that sit on top of it, including then at the very end your applications. Absolutely. So because you mentioned SAP, it's interesting because they published, I think 2 weeks ago, a very interesting new model for tabular data. So they are also now on the battleground when it comes to models. It's an open source model. You can use it for your tabular data. And I think the CTO was very, very enthusiastic and published and did a great LinkedIn post, and there was a huge PR campaign behind the whole model. So they are also launching models in their specific domain. For sure, tabular data is a huge topic for SAP. I will link to the model in the show notes. They published a paper and the model. Yeah, very interesting.
Yeah, I haven't thought about it further here, but as I said, I mean, a huge company, and I assume, intrinsically, implicitly, externally, that their data about you and tens of thousands, if not hundreds of thousands of companies running your company. So your company data, so your sales data, your marketing data, is somehow, somewhere, and I don't know what is that base, in some kind of, let's call it a database. And if it is already there, let's say tabular, or if you get it out in a tabular way, I assume that they have a huge interest, playing in that market, which we haven't been typically been looking at.
With Frank, we went there with Frank.
Yeah, that's what we did. But from a topic perspective, we more typically look at our production at the shop floor, stuff like that. We have been looking once or twice at forecasting, I think. Now let's mention it. Yeah, I just said I didn't sleep very much because I came home very late. That was from the Machine Learning Week in Berlin, and there was the Krombacher. Krombacher is a well-known beer, not only beer. They have also all kind of other beverages, and he was also looking into or sharing with us the forecasting. What is going to be the need for any of their beverages within the next 2-3 days. So that is something we've been looking at as well. But SAP has always been on the side a little bit, I think, for us. Let's see if that's going to change. Maybe, who knows?
Absolutely. Maybe it's interesting. Yeah. There's a new startup in the US called Prometheus, and its CEO is Jeff Bezos from Amazon. And they have already raised billions, hired over 100 researchers, and one of whom we both know. Do you know who?
No. Should I guess?
Yes, you can guess.
No. That's going to be very... No, I can't do that. Then people are going to be very... Say, how could you suggest my name? You know that I'm very happy at my company or whatever. No, I'm not going to do that.
No, it's Benedict Alkin.
Oh, really?
Yes, Benedict was a student at SAP Hochreiter, then with NXAI, XLSTM Vision was a topic. Then he was with MEAI, with Johannes Brandstetter, one author of the Neural Dam paper, and now he is with Jeff Bezos. Yeah, congratulations, Benedict.
I do not know personally, but I know the name of the other person who is actually going to be working there. That's what I read about, which is Jeff Bezos.
Yeah, exactly.
Yeah, I mean, the message I started reading.
Okay.
In the little time I had available, and it said that he is going to be actually working as a co-CEO.
Yeah, exactly.
But I stopped then there. Why did I stop? And you picked it up, maybe because personally as well. But what did you say? What is their topic? What are they going to be doing?
Their topic is aerospace, computers, and cars.
Aerospace, computers, and cars.
And there was an interesting repost by Elon Musk, and he said, "Welcome, copycat."
Oh, really?
Yes. Yeah. So very interesting, but I think it's a huge success for the Europeans that Benedict is a part of.
Part of it, yeah. Okay, and the guys behaving like children in the playground, right?
Yeah, exactly.
Oh, this is my castle. You're not allowed to build a castle as well.
Yeah, exactly. So, Benedict, we keep our fingers crossed for you and your research. All the best.
Oh, space. Space is a big thing.
Aerospace. Yeah.
Space is a big thing here for us as well. We have this, I just heard a radio news about how Bavaria and, tell me, what is the other province that we have around Düsseldorf, let's say?
North Rhine-Westphalia.
Very good, thank you very much. And they are both kind of fighting who's the number one in space, because within North Rhine-Westphalia, we have at least that's where the European people who go into space, there is this
European Space Agency. Yeah.
And I know from our prime minister in Bavaria that he's been saying, I was there personally many years ago, And again, that is the area not too far away here, south of Munich, where we have Airbus and we have many with this huge extension of the technical university actually here, all about space. So that's
and the DLR, right?
That's that one, but also companies like Helsing. And then when we talk about defense and airspace, and so that's concentrated here as well. And it's you see so many messages these days here. So I think it's a global thing taking place. Interesting that that Bezos is moving into that space as well here.
Yeah, but he already has a spaceship or something. I think so.
Oh, yeah, his own spaceship.
Yeah, I think so. So, yeah, but with Prometheus, he wants to go further now.
Oh, okay.
Yeah. Together with Benedict.
I've got a message here from Jaime Calvente Mieres, if I pronounce that correctly. He may be Spanish, but I think he actually is based in Düsseldorf or close to Düsseldorf. I looked at it specifically. And the reason I say it is because he's a guy passionate about designing scalable PLC architectures, integrating robotics with AI, industrial automated systems. And he took part, or he is taking part, maybe that's probably the right way to put it, in the Hugging Face MCP Serve Hackathon.
Okay, what is that?
And he said he'd focus on how agentic AI can support and transform the world of industrial automation.
Okay.
A space he's deeply passionate about. So I asked him to keep me informed. So maybe we'll hear more from him before the end or beginning of next year.
Oh, that's good. My last news is the Cosmos model. I don't know if you are familiar with the Cosmos model.
Maybe, sure.
Yeah, Future House has published a new AI scientist, and these scientists is called Cosmos. And the model produced 7 discoveries across multiple fields, not summaries, not prediction, actual findings. And these findings were later validated by humans. And this is crazy. This is absolutely crazy. They found something with diabetes, and it's very, very interesting. It's in the same direction as Max Welling from Cusp AI, discover new materials, and enthalpic and stuff like that. And I'm linking a good thread from Twitter or from X to the whole Cosmos model in the show notes. It's very interesting to read how these models act. Yeah.
I saw a quote here, but it was in a German tabloid, and I only saw the quote, and I started reading 2 sentences, and that was enough for that moment. But nevertheless, it stays a huge topic. All of this, under the umbrella of AGI, I guess. Well, or maybe it's not yet AGI, but all these separate messages moving into that direction, a huge development. I must say that, as we bring these topics, we would not have brought them a couple of years back when it was all about singularity 2045. And I did now actually write we talked about him last time, the Australian guy who said 2060, right?
Toby Walsh.
Toby, if you're listening, I haven't heard back from you because, I had a very specific topic for Toby there. I haven't heard back. And the fact that we talk about it, at least that we bring these messages every now and then, at least for me, and I assume maybe same for you, is that we are maybe changing at least our perspective. I know exactly the quote. And when I say that I wrote about it, it's because that was a thought I had. And I think I was sharing with a business partner. And I said, yeah, sure. If you write things down, it's very good for making your thoughts explicable. And I know very well that I said explicable with regards to the singularity happening. I must have written something like, as soon as he put a year to it, which was 2045, right? I said, that's not serious. And then Toby came with a 2060, and now we're talking about these topics. And it's only 2025. In the year 2525. There you go. I did that before. Robert, there is NXAI. You heard of him. They're running a time series foundation model on a PC.
Oh, not on a PC, on a PLC.
Oh, yeah. What did I say? PC. Yeah, I meant to say PLC. So what I read is what a Tyrix is running on the Control X core and starts predicting. Have you heard of it?
I heard of it, yeah. But I'm biased, you know.
Yeah, I know you're biased. I don't remember, but you can still. Well, as I said, what I would love to, maybe then not from you, but nevertheless, I would love to see or hear, maybe then from the responsible person for the Control X about the use case. And specifically, I was interested in not less in the capabilities. Sure, in the end, as you said before, the capabilities must be good or better than other ones. If not, you're not using it. And then my number one question was, so if we're now within, and I assume, an industrial production environment, a Control X typically, right? What does that mean? So what is the job function of the person, running the forecasting classification? Now, and everybody is biased. Of course, you're biased, I'm biased. And whenever people try to get bias out of models or I think where that's not going to be very easy, I think, because and the reason is, if I ask a question like that, of course, it implicitly means like there is an expectation that maybe it's about this democratization by AI, that now a person who has not been studying, let's say, data science, and then I will move back quickly to Berlin and share with you one very interesting session yesterday. But it's the person who has been, in charge of the typically, I assume, and that's then more specifically the question, the MES system. So the MES was showing some data, and then the person, but nevertheless, things were happening. And then the person was asking maybe the IT or the data science department, I don't understand, why is this happening? And maybe when they had the time, it's a little bit black and white here, but maybe months later they had time and they looked into it and they spent them a week time and they told them this or that is happening. And then the assumption now is that in the future with a solution like this person who has been the MES, shop floor person, can do this themselves. So maybe you can just bring me into contact with the responsible person, then will be good there.
Yeah, thanks to Hans-Michael Krause, especially from Bosch Rexroth, because he's very keen to do that. And it's a proof that you can run, it's a big thing that you can run a foundation model on a PLC, because it's only 35 million parameters, but you have the XLSDM architecture. You can adapt this architecture to the chip or to the environment, and it's huge to run a foundation model. Yeah,
I'm very much looking forward. And I'm going to make that link back to now almost 10 years ago, right?
Yeah, we were the first podcast talking about edge AI, I think. Yeah. Yes, really.
Yeah, right. I know. Yeah. I know. That's one thing. But the other thing is that we were a small team. We were so excited. And we had these, and that's the topic I'm going to link back to yesterday as well. We had these two data scientists from Cluj, Romania, right?
Mm-hmm. Yep.
And they were really, that was, for me, it was so I was so interested in what they were capable of doing with their, having studied data science in Cluj. And we at Softing work with them there, and then bring it back to what is possible today. And at least there is this assumption. I don't want to move it, so I'm going to wait until I'm going to have the capability of talking with Hans-Michael Krause, who we were sitting on at Hanover. When was that? Half a year, maybe a year ago. In the meantime, right? Very good. And the link back is that yesterday there was this, so one minute max, only half a minute maybe, is the machine learning week. Although it's still called Machine Learning Week after more than 10 years in Europe, and then even later it started in Silicon Valley actually. Although it's called that, there's loads of Gen AI, maybe they're going to change their name sometime to better represent that. But there was one of these table discussions, and that was done by an AWS guy, and it was about, I think the term was towards autonomous AI. And although it was not in my room, so I as a moderator had one room, but during that 1 hour, I moved to the room where this was the topic, because in my room which is only your topic, how do we call the new chips, which I always have said is your topic, where IBM was always big.
Quantum machine learning.
So thanks. It's so far away from my brain because when did we, 5 years ago, we agreed that that was going to be your topic, never my topic, because it was never ever going to be ready.
Your topic is agents, right? Agents.
Yeah, but also it was never going to be ready within the time that that I was actively involved in. So I moved to that other room, and that room was completely filled, which means that in the other room, let's say there were less people on the topics, and that is not the thing. But the point is, I was doing. Must have been 2 or 3 years back. Not sure. I think it was in Munich, or was it in Berlin? And I did one of these table discussions, and that was about exactly at that time the same topic. ChatGPT had just come out with a thing. They called it whatever they called it. I forgot. They changed the name of it as well. And they said, tell ChatGPT where's your CSV, where's your Excel? Okay, here it is, and just tell it to start analyzing. And it not just to ask smart questions, because how can you ask smart questions if you're not a data scientist, right? I mean, but let's stick to the shop floor MES person, what you want to get out. And then it was already at that time making me all those suggestions. What do you want to know? Do you want to start with basic statistics first? Do you want to do this diagram? Do you want to? And I thought it was so impressive. And at that time, there came 2 persons to my table, and they were questioning. They were just completely putting up their deflection shield, not telling me so much, but almost like this is bullshit, right? That was 2 years ago. Yesterday, there must have been 50 persons in that room. So there was not just one table discussion. There were, I think we had 8 table discussions on the topic of towards autonomous AI. So how you see things change.
Yeah, absolutely. And maybe one last topic, because there's a lot of hype surrounding the topic token-oriented object notation.
Oh, yeah, I saw that as well.
It's the next big thing in quotation marks. And I will do an interview with Aymar Silver from Portugal. He's a software engineer at Capgemini, and he wrote a very interesting article on JSON and the technical obsession on LinkedIn. It's very interesting. I will link it in the show notes about token-oriented object notation.
Oh, yeah. Looking forward to hear from a specialist, because already after 1 week of hype, I saw people doing comparisons that were not necessarily that positive. So
exactly,
but I'm very much looking forward to. I've got 2 quick ones. ARM is proud. Breakthroughs happen every year, they say, but only a few redefine what's possible. The ARM-based Meta Ray-Ban display glasses and EMG wristband are among them. So then I asked, in my humble opinion, people wearing them, and I will not use the term from 10 years ago when Google came with a similar solution, right? They will nevertheless not only not be given permission, I believe, to enter areas with people without. In public, people without them will turn around or hold their hands in front of their face or run off when running into those with, at least. And bringing that to the environment, I think we've had, there was a time around when Google brought their Google glasses. Meanwhile, probably 15 years ago, they also looked at the use of it within, at least, let's say, logistics, probably typically, right? The people who got the SKUs out of the stock, that they would have it
pick by light stuff and stuff like that. Yeah.
And they would have their additional information, right? And already at that time, I think there were tests and recall. People were getting headaches because of it. I'm not saying that this is still happening, but at least I'm not looking forward to be seeing people wearing. And a question to you is that then the glasses that the Meta guy is wearing on a picture you see these days?
I think so.
Big black.
I think.
Is that the reason
why? Yeah, I think so.
I thought it was just some kind of modern thing, but
no, Peter. No, Peter, you are not into this. Yeah, so yeah.
No, I know. And the reason I share it nevertheless, if some of you, dear listener, are questioning why is he bringing this, it's always about you then thinking about, can I use this technology in my own typically industrial environment or not? That's the point.
Exactly.
And a final one, and one person, maybe he's not going to like this too much. Maybe I was just in this mode yesterday, but there you go. He is Gianluca Brugnoli. He probably Italian guy, right?
Yeah.
So he's the VP designer at TomTom.
Okay.
TomTom
Navigation.
is Amsterdam-based, right? AI is not killing UX. It's proving its importance. Even the most advanced AI needs a good UX to unlock user value and drive adoption at scale.
I'm skeptical.
And then Peter says, playing devil's advocate. Yeah, somebody has to do it.
Yeah.
Why can I not talk to the AI? Sepp Hochheit told us years ago. I think you were doing the interview with Sepp, right?
Exactly.
5, 6, 7 years ago. A user should be speaking to the machine. Be careful with the speed. No problem. The machine replies, I've got new special oil, so I can go faster.
Yeah.
Now, today, when I need an answer, I'm getting a new that's really, I should almost be telling this, but I'm not going to do it. I had to buy a new, in this case, a Google Pixel will come because the other one is broken. But if I ask it my Google smartphone, and Gemini answers by voice, that is my standard. And I could use any of the other ones as well, right? So my question then is, what more do I need than e.g. a T-Mobile? There is T-Mobile again, because I think they were the first ones with just the screen with no apps on it, right? So then I said at the end, please, you UX designers, including you, Tom, and you know which Tom I mean, do not throw stones. I'm just asking.
Okay, perfect.
Yeah, but we need to do it, right? I mean,
but I'm very skeptical when it comes to UX, because AI has so much capabilities, and you see so much different approaches. And you can, I remember 2 years ago, Beckhoff presented something that you can prompt HMI for your machine very, very easy. So I'm very skeptical when it comes to UX. Yeah.
Right, but all of that is, I would say, UX, right? That is the point. And maybe, when Gianluca, talked about that, that's all that he meant. But then, and I must share with you, if I haven't said already 100 times, that I'm, the number one happy minimalist for a long, 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 long time. So, and I've agreed with Tom, the UX specialist that we both know, on when I sit in my car and I need to move my finger on the radio screen and I miss it and I'm distracted from the road. We always agree there needs to be a second way of doing things.
Exactly.
For example, but that's the final one. And I think we need to ask these questions ourselves. And again, you, dear listener, you will be asking as well, what does it mean to my user interface design? Maybe you yourself are designing, or you are a customer, internal customer, and you start thinking about, well, do I need this or do I need it a different way around?
Because you mentioned Amsterdam, let's move to the main part, because we have an interview with Professor Stratis Gavves, and I recorded the interview a few weeks ago about World Robotic Models and what is the difference between the World Robotics Models from Amsterdam in comparison to Meta or Google, and why do not the traditional machine building or robot companies are not publishing World Robotics Models. So very interesting discussion with Stratis. Yes.
Looking forward to, as you mentioned, Meta, the other guy who has been at Meta, but not anymore. I understand he's also very interested in building world models, at least, right?
Yeah, everybody's looking now at world models, yeah.
Okay, and we are going to be looking more detailed, looking forward to the interview first, and then as a very good basis for understanding, and then we're going to be
in Amsterdam
in January. Looking forward to you.
Peter, thanks a lot. It was a pleasure.
Thank you, Robert. Have a good day. Dear listener, have you with us soon again. Bye-bye.
So, my guest today is Professor Stratis Gavves from the University of Amsterdam. Welcome, Stratis.
Well, thank you very much for the invitation. It's a great pleasure to be with you.
We want to talk about world robotic models. We know models from Meta, from Google. They are all working on world robotics models. You and your team are also working on robotics model. What is your approach in Amsterdam?
So I am a strong believer that in physics and causality, physics informed and causality informed neural networks. And in a way, this is actually quite the opposite of what is the current trend, where scale is all you need and data is all you need, is that the main narrative, like that's how you train ever bigger LLMs and so forth. I think that we need better inductive biases, better knowledge in the system, and knowledge about physics and about causality. Especially about physics, I think it's crucially missing, not only because, like physics is something that we know since the 1700s, and it hasn't changed. Why wouldn't we add it directly to our systems? I think that's going to save us a lot of imitation and a lot of retraining. So it's also cheaper in terms of data and in terms of energy, but it's not just that. I think it's also a matter of trust and of trustworthiness.
Mm-hmm. Why? Can you explain it a bit?
Because things that do not, models that do not follow the physical laws are models that are absurd. Like, imagine if a model would suggest that an apple, instead of falling down because of gravity, would start floating. And once you start having these kind of models that are so obviously absurd, then you start doubting everything else that the model delivers. I mean, if it's like a good prediction, how do you know that the next one will still be good, or will still be relevant? I think hallucinations are pretty problematic with LLMs, but I cannot fathom how deeply disturbing hallucinations would be with physics. Imagine a robot that doesn't understand simple physical laws. So I think we actually need much more precise and explicit physical knowledge to our neural networks and to our systems. And we need it as soon as possible. We need that before mass deployment in practice in homes and in factories and so forth. Causality is also very interesting, let's say, type of knowledge that we need into our robot learning systems. But it's, that's a whole new can of worms that needs to be checked thoroughly and properly.
Why do the big ones go a different way than in contrast to your approach?
Well, in all directness, what they're doing now is in their business interest. It's their business model. They can definitely scale up GPUs and they can definitely scale up data. And at the end of the day, that is a strategy that has worked beautifully well until now with language. So, when you have a winning horse, you keep betting on it. But I think robotics and physical AI, embodied AI, is a class of problems with very uniquely different types of challenges compared to language and natural language processing. So the same approach that works for chatbots is not going to be enough. And mind you, I'm not saying that we don't need data and we don't need skill. We definitely need it. I'm only saying that it's not sufficient. It's necessary, but not sufficient.
Mm-hmm. How do you incorporate now physics into the models? What is your approach?
Right now, what we're exploring is integrating two of the most exciting advances in robot learning, in my opinion, robot learning, computer graphics, and AI in general, which is Gaussian splatting. And
what is Gaussian splatting?
Gaussian splatting is a technique that was initially proposed for graphics reconstruction. So basically rendering a scene. So basically by taking a video of a scene, like moving around, and you put it into the Gaussian splatting algorithm, you could reconstruct a really photorealistic model of the 3D world very, very quickly and very, very efficiently. So you don't need huge computational resources and so forth. This works really well. And we had the idea, what if we repurpose this for robot walls? And some of the, the method had to be a bit adapted. So we have to integrate knowledge about objects, about textures, about the geometry of things, and so forth. It was not we managed. We integrated Gaussian splatting after this first step with explicit physics engines. And basically we had a perfect physics simulator, but now for the real world, were originally proposed for, abstract worlds or generic worlds or perfect worlds, if you may. Now you can have physics simulator for your world, like the world before you, exactly like Robot is seeing. And I think that's a very exciting opportunity. It really works very well. And I think actually there is a great interest, like more and more papers are actually following exactly this approach. So I think that's very nice.
So, but you have this Gaussian splatting, and now you integrate. Can you please share a bit more in detail how you integrate now the data in this approach, and what is the outcome at the end?
So in our approach at the moment, we're basically, right now it's more of a system. We don't really have much of learning, to be honest. What makes things even more interesting, because imagine what else can you do? Not, we can add data to the whole thing. So what the system, what the model does currently, it returns this, like what we call explicit world models. So world models are basically models that, models of the world, as the as the name says. And what does this mean? That this model takes as input what the world looks like at the moment, and it also adds, like, it receives as input possible action. So let's say I'm in my room, and if I grab the door handle and rotate it, then the door will open, right? So the world model tells you that what is going to happen given this action of turning the door handle. Most methods until now are what we call implicit world models. So it's a neural network that basically tries to reconstruct this world in standard neural networky way. With our Gaussian Splatting plus physics engine, we obtain explicit world models in the sense that we can explicitly now reason about the physics of the world. We don't expect that the neural network returns predictions in a black box type of way. Rather, everything in our explicit world model is explainable, is, interpretable. The next step is to start adding data to the system. So for instance, what we're working on now is also pairing this with vision language action models and pairing this with diffusion models and generative models. And by doing that, we can also not only try to reconstruct the current world, but generalize to any type of world and learn from data learn from the interactions from this data.
So the modalities are vision data, simulation data, time series, or am I wrong?
No, you're absolutely right. Like right now, the data is, basically we're using vision data. We're using like time series. Especially if you want to have policy learning, like reinforcement learning with a robot, we're using depth sensors. We're also exploring how to use language instructions, especially when you're, again, learning a policy. But for what is worth, we're quite multimodal in like fundamentally, like there is nothing that precludes us from using any type of a robot sensor and integrating to the system.
Do we will have multiple world modeled when it comes to robotics, or is it only one unique model? What is your opinion?
Good question. I think we already have multiple world models, so maybe the question can also be rephrased to whether we're going to have one, model that basically outperforms so much more everything else that it's going to be like the ChatGPT of world models. I think we do have some very strong, or at least some very popular, like models that people know from NVIDIA, Cosmos, and so forth. In my opinion, we're not there yet. These models are pretty good when it comes to specific applications, especially those that they have been like trained with. But I think it remains to be seen whether they can generalize to out of distribution situations. For one, we've been testing their physical and causal capabilities in some of our works. And, there is still room for improvement, let's put it like that. Now, our world model, the one that we have, the drama world model, I would say is also not the complete answer yet. Like the original publication doesn't have any data learning, although we're working on it now, and it's very interesting, very promising results. I think in the end we will have at least a few different variants. Like, I believe in the future we'll have a system 1 and system 2 type of approach. We will have an implicit world model for system 1, like for giving the robot the capability to quickly decide and make decisions, like neural network based decisions on how to act. And we will also need a system 2, like explicit world model, like something similar to what we propose, that can tell you more explicit about the physics of the world, that can integrate more explicitly, can use more explicitly physical knowledge and causal knowledge. And this is going to be a bit like slow, in quotes, like slow thinking.
So a world model means it could also have smaller models in between, or is it a substitute of smaller models, or what is the idea?
Yeah, for sure. For sure, it's going to be like, I mean, especially when it comes to edge computing and robots, for sure, you cannot have a one size fits all situation, right? Like, even if you would have some really high end robots that have very big memory, very strong compute, you have also many more devices that will be like, they wouldn't have like this big capabilities. But either way, I think like with robotics, you've got like all sorts of unique other challenges: efficiency, data efficiency, memory efficiency, compute efficiency is key. Dynamicity is very important. I think it's very hard to judge at the moment whether we're gonna have like one or many, but I think we're gonna have many because the world is so rich and the problem is so complex that it's quite hard to expect that a single model will be able to solve all different situations simultaneously.
That sounds like I need a marketplace or for embeddings to solve all the different approaches in the field of robotics.
And yes, I think at least for the coming time, I would expect something like that to be, needed. Like in practice, I mean, like I cannot imagine how else.
Mm-hmm. So you see, you will have lightweight models on the edge, on next to the robot, and then you have a bigger model in the back. Is this the architecture you suggest, or can you share once again, please?
Yes, I think for sure in the coming years, I expect to have robots will be working very well in terms of understanding perception and so forth. But like their planning, their communication, their interaction capabilities with the rest of the world, I think that's something that needs to be like better research, especially because with robots, you have no room for failure. You cannot have a robot that does mistakes, in my opinion. And in that case, we will need lightweight models that will be working on simple devices and on smart devices, and also, and maybe with sensors of the robots. Like maybe you will have a different world model per sensor. And then you would have a bigger model, like a system 2 type of model that guides the bigger planning and the bigger thinking, let's say, of the robot. And of course, how you communicate between these different models, the lightweights and the bigger ones, that is, the name of the game, I think.
Okay. But do you have an idea how to communicate between these models?
Well, I have lots of ideas.
Okay. You don't want to share. You don't want to share your ideas.
Well, I mean, I'm happy to share with interested parties, but yeah, no, I think like there's like lots of exciting prospects actually when it comes to like real world robotics. I think that's going to be the next revolution. And what is actually very interesting is that there is no clear winner. There's like so much room for improvement. I think like the first delivers a strong solution, a strong, maybe practical solution even, is going to be, there is some land grabbing to be done here.
We will see the same story as we saw it with LLMs. So there's one front runner, and then a lot of people will follow. And we have like Gemini, we have ChatGPT, we have Claude, we have Qwen, we have some Chinese, we have open models. So we will see that also when it comes to world robotics models.
Great question. I think, I mean, it's inevitable that you will have many, many models. Again, the question is whether one will be so clearly better that, wins everyone. I think it's going to be harder because with LLMs, I mean, everyone understands language. The chatbot works, whatever, like in your phone and your laptop, everyone can judge whether that works or not. But in robots, like, it's much more, like real world, like physical, much more, that you have to, how many people are going to have robots to begin with? I think it's going to be much more fragmented. Like it also depends on how it's the communication that we mentioned before. Like there is no good, I think, engineering solutions for a lot of practical problems on how robots are going to be in our like integrated in our everyday lives, in the factories and everything. Like so, until like all these things are like universally solved, there's going to be, I suppose, there's going to be a lot of like heuristics and a lot of case by case solutions, which means that there are going to be also a lot of models because they have to cater for all these different situations. Until when there is like a model, like, or at least like a layer, like a solution that somehow solves these practical challenges, and then I think that's going to be like, that's going to be the land grabbing.
Okay. At the end, one question from your perspective, because why don't traditional robotic or robot manufacturers do not develop world models? Or are we just not seeing it? Because when you Google world robotic models, you see Meta, you see Google, you see some humanoid robot producers, but you don't see robot models coming from KUKA, from ABB, from Yaskawa, you name it. Why don't robot manufacturers develop world models?
Because perhaps it's a different problem.
Okay.
The traditional robotics manufacturers, they deliver outstanding world-class technology on the actual robot, the hardware, but understanding the world, so giving the robot the capability to interact with the world, that's like a whole new challenge of its own. And I guess when you've got like a very thriving and very strong company, you have to focus on what you can do really, really well. I think like the companies that you mentioned, they're delivering top solutions in factory settings where you would assume or you expect or you dictate the world, and then modeling the world is sort of implicit. You solve this problem by making sure that the world is not going to change, but the next generation of robots that are not anymore in prescriptive environments, they're not like too constrained at least. These will need a better understanding of the world, I think, one way or the other. And, maybe KUKA and all the other companies, they have to do it, or they have to work with somebody that does it.
They're losing an entire market, right? So at the end, you're only then the hardware producer, and the money is made with the world robotics models.
Yes, robotics as a technology exists since like a few decades now and has really progressed amazingly, right? Like it's like, in a way, it's what led us here. But, I don't think you can really take a robot that the best and the most state-of-the-art robots, but in Siemens or in Toyota or in Bosch or in whatever other big factory, you cannot take that one and then put it at home, right? Like you wouldn't trust it. I think you need a different, like, even type of technology. It's not like you cannot reuse the old technology, at least not alone. It's necessary again, but not sufficient.
Mm-hmm. Stratis, what is on your desk for the next coming months when it comes to robotic models?
I think like my team, my lab we have a very interesting, let's say, position because we're one of the very few teams in the world that has collective experience in both physics-informed causality, like world models, robot learning, and so neural network deep learning and so forth. So my plan for the coming months, for the coming period, is really to double down on this, like make sure that we do have physics-informed causality models for robots and for world models. I think that's absolutely necessary. I cannot believe that we'll have a robot learning type of world, like a robot learning type of situation where we're going to have robots amongst us that they don't have explicit understanding of physics and causality. I would not trust my kids with a robot that cannot tell me exactly what the thought process is, that possibly hallucinates, that I don't know exactly its reasoning steps. And I think like for most companies, this opaqueness, this lack of transparency when it comes to robots is a no-go, right? Like because there you can have actual physical harm and nobody can tolerate this. So that's what I plan to do. I think like all the other companies or all the other groups that they focus on like putting more data and more scale. I think this is absolutely necessary. We need it. We're going to use it. Maybe we'll also do it a bit, but that's not enough. I mean, no matter how big compute, no matter how many GPUs and data you put into a robot, it will still not be able to reason in an explicit manner. And I think that's something that we can definitely deliver. We have already partly delivered, of course, in a demo sense. So that's my plan. And I find it also exciting. I find it's like a very, very, like a missing piece in a way.
Stratis, thanks a lot. We keep our fingers crossed for you and your team and your approach. Thanks a lot and greetings to Amsterdam.
Thank you very much.